All right, so welcome to the July 25th meeting of the Resource Management Work Group. Got 2 items on the agenda today. First item being the CPU Manager Deep Dive. Connor and Seth care to take us through it, and then we'll have a hard stop at 30 minutes if it takes that long to make sure we can do the second iteration of last week's discussion around device plugins.
All right, so I'm sharing the screen. Can everybody see it? Cool.
Yes.
I got a thumbs up from over the desk, so call it good. Okay, just starting at the top, I guess. What problem is this trying to solve? One was one that you, Derek, at Red Hat mentioned was, I think you mentioned that you were involved in some bake-offs with some other scheduling systems that were VM-based, and you observed poor, unpredictable performance compared to some of those other systems. So higher application latency and lower CPU throughput. And there's a hypothesis that a large portion of that is due to the CPU quota being fulfilled across multiple cores rather than an exclusive subset of cores. Cool, someone muted. And then the other use case we had in mind here was, scheduling virtualized network functions on top of Kubernetes and containers, which, some people are starting to do now. And the latency that's added by the operating system process scheduler can blow latency budgets for some of those workloads. And so the main point was to try to do something for those two use cases. Solution requirements. Here we have, basically a requirement that the contract is API driven, but doesn't expose too much of the underlying topology of the node. And so this proposal uses only the existing resource request and limits in the current container spec. And so if you're of guaranteed QoS class and you request an integer number of CPUs, then there's at least one policy that will try to make sure that you get all of your quota from reserved cores so that you have fewer context switches and higher cache affinity. So that's really the main requirement that we're getting to. Second requirement is that you may have sidecar containers such as log forwarding or processing or metrics export or any sort of non-critical workload that's a sidecar container. And we want to support that use case where one container is treated as latency critical and the other one is not. So we don't want to necessarily dedicate an entire exclusive core to something that's just doing something on the side that's not important to actually serving user requests. Number 3 is that we want to avoid capping CPU quota for guaranteed containers because that would be counterproductive with respect to number 1, and also take physical processor topology into account. So there's a big section down here about, well, I guess we can go through the block diagram first, but there's another section that I won't go through that basically motivates why CPU topology is important. If anyone on the call wants to go through that, we can, but I think everyone is pretty much on the same page with that topic. So any questions so far, or should we keep going?
I guess it's fine to keep going.
Okay, cool. So in addition to the proposal, we've also been working on a POC, mostly between Intel and Red Hat. And so what we've done here is kind of to outline the pieces that the code has, I guess the shape that has taken place in that POC. So in this picture, we have a block diagram where all of the light blue boxes are new stuff, and the arrows indicate where we're either interacting with existing components or whether existing components interact with us. And so the main flow here is that when a container is created, the kube runtime calls into the CPU manager and says register. And as part of that registration, the manager delegates to CPU manager policy. That's the pluggable piece that we'll talk about later. We have multiple policy implementations. And inside register, what you do as a policy implementer is to update CPU set mappings in a state abstraction. And that state abstraction is read by the CPU manager in order to write back CPU set settings through the CRI using a new method in the CRI called update container resources. So I'm suspecting that this piece will be one of the more contentious issues, but yeah, we can talk about that when the time comes, or now, if anyone has input on that.
Yeah, I mean, practically, I don't know why it should be contentious. Like, is there a particular runtime that we're aware of that prevents updates now? I think you guys have investigated that at least the versions of Docker we target work fine. We know runc should be able to work fine. Are there any runtimes where we don't work fine?
Sorry,
not that I'm aware of. I mean, I've got a PR open specifically for this change that's not associated with the PR for this proposal, and it's been met with apathy, is what it is. Not objection, but just no one has looked at it. So, yeah.
And
so we haven't tried it with any VM-based CRIs, but that would be maybe one last thing to check for hazards.
yeah, but I guess even with them, though, maybe they would not run. So you haven't touched down how some of this is keyed off of the CPU policy you run with, but it seems like it'd be agreeable that they would just not run with that policy.
Yeah, and it's an addition to the CRI, and so the implementer of the CRI is free to ignore it, I suppose.
And then, generally speaking, if we ever supported in-place vertical resizing of pet pods, wouldn't we still need the same method?
Yes.
Okay.
Yeah, so I think it's the vertical pod autoscaling is would be the other user of this this new API.
So I couldn't tell if I heard Vish say something around the use case, but if not.
I was asking, like, what is the exact motivation for this? Is this just like go and change the series and maps for existing domain?
It's really hard to hear you, Vish.
Is the use case for this new API that of like removing CPUs that are available to running containers and giving them exclusively to new containers?
Yeah, so well, specifically for the static policy, there's a lot more detail below, but what it does is before you're running any of these special containers that are supposed to get exclusive cores, everything is as before. So if you have a burstable pod or even a guaranteed pod with non-integer CPUs or a best effort pod, they would run on all of the cores just like they do now. But when one of those special containers shows up, then we have to remove those cores from the CPU mask of everything else. So that's the major use case.
Would it simplify if you were to say that like exclusive cores are only granted to pod level? Would that be like breaking a bunch of use cases?
I'm not sure what that would fix, but I haven't thought it through yet.
So I thought we discussed this before, where the changes had to be made bottom up, not top down.
Right. So I'm just asking that, like, what if there are no restrictions at the company?
Vish, I can't hear you. Can
Yeah, I'm still having trouble hearing you, Vish.
I have no idea what's going on with my laptop. So I'll try to get like really close to the form. So I hope you'll bear with my big screen on big face on a screen. What I'm asking is, what hypothetically, if you were to say that all the CPU set masks are applied only at the pod level and not at the container level, what sort of use cases would that break?
Well, it would break the sidecar use case. That's in the requirements section.
And how critical is that sidecar use case?
Well, for the original use case that we had in mind, which were customers that were trying to do NFV, it was basically a blocker.
You also have the problem that when you're changing these CPU sets, you have to go down to the container level. There's no avoiding that, because you have to. Derek was saying you got to go from the top down.
Is
No,
it
bottom up.
Well, yes, yes. It depends on which way your tree's going. Yes, but you have to start at the leaf. Well, it depends on which way you're moving it, right? If you're making it, Connor had a clear way of saying this, and I'm going to muddle it, but it's if you are making the CPU set more restrictive, then you have to start at the leaf and work back. And if you're making it less restrictive, you got to start at the bottom and go toward the leaf.
Yeah, I guess like it's basically the API issue at the C group level then, because if you're not setting any explicit restrictions at the leaf level, then the general expectation is that the leaves would just like follow the restrictions applied at the parent level or somewhere up the tree. But if each leaf is getting defaulted, and then if you have to go update those defaults, then it's sort of annoying.
Yeah, that's the way it works. It inherits, and then if you want to shrink the parent, you have to shrink the children first.
Okay.
Unfortunately, yeah.
Like not now, but like we should see if we can fix that API. But go on.
Well,
So do you have a particular concern, Vish, with exposing this method in the CRI? Like, it seems applicable, seems useful for a variety of other future targeted use cases.
Yeah, so I was only trying to understand the motivation.
Okay.
I was not questioning whether we need it or not.
Okay. All right. Just to make sure we're on the same page.
Okay. So I guess just looking at the diagram again, we covered the entry point, and we covered how the C group gets written by the CRI implementation. That's how it actually makes it to the C group FS in the end. C group manager requires the pod status provider in order to get the container ID once the container is running, so that we can actually pass the right stuff to the CRI so it knows which one to update. And then there's an internal interface that abstracts just a couple of methods from the kubelet to get the machine info. So we're using C-advisors, CPU discovery, existing CPU discovery mechanisms to populate a topology construct inside the CPU manager. And also we use it to get pods. So basically the CRI is called with this update container resources in two places. One is in register, and the other is part of a reconcile loop that runs, and that's basically how in the case of the static CPU manager, how the containers in the shared pool get basically how they reconcile with the current CPU set for the shared pool. Sorry if that was a meandering description, but I hope it made sense.
So the one question I had is, say I have a pod with two containers. One of the containers gets created and starts just fine. The other container creates but doesn't start. And somewhere in between there, let's just imagine like Docker or something, like it times out and the kubelet then says, oh shoot, let me delete the container and create a new container and then try to start that one. Is my CPU assignment changing each time there, or is what would I expect in that type of flow?
So the CPU assignment is it's set in between create and start. And so if start fails, I'm not entirely sure how the logic goes inside the kube runtime for that. Seth or Vish, do you guys know what happens if that occurs?
I'm not entirely clear on it, but we need to make sure that in all those error paths, we don't basically, allocate CPUs to a pod that, basically goes away, but doesn't go down the CRI path that we already intercept for the free. But basically make sure that, for every allocation, there's a deallocation, and you don't have pods that are erroring out and taking up CPUs and eventually depleting the pool.
Yeah, so I think Seth's familiar with the situations that I'm talking about where we've seen plenty of cases in the kubelet where between create and start, something bad happens. And I thought that it destroys the existing container, but I would just like confirmation on that.
Yeah, I mean, we had this issue with GPUs too. So in that, like, whenever you do allocations, you should just mark it per pod and per container. And then just remember that, so you don't have to keep making those decisions over and over. Like, I didn't ask this question, but I was hoping that as part of like bringing up a pod, you would have a phase where you would figure out like what sort of CPUs it's going to get, if any, and then like what sort of other devices it's going to get. And then you'll be having a static allocation map prior to even attempting to like start the pod. Like, you want to make sure that you can satisfy all the pod's resource requirements before you go ahead and start it. So as part of like running those feasibility checks, you would have already figured out what the static allocation map is. And then from that point onwards, it's only about converging towards that static allocation map in the case of CPUs. Yes,
that's what we do. And there's, because it's the static policy, there's no convergence. I mean, if we can't allocate the CPU, I know that we talked about this. I'm not sure if we bail out or we just like log. It's like, hey, you had a guaranteed pod with integer resources, but we couldn't allocate a CPU for whatever reason. But we don't want to block your pod starting because of that. So you just get basically no op policy behavior from your guaranteed pod.
Yeah, but I think, Seth, we'd want to maybe do that earlier in admission or some other phase. If we can't, we shouldn't be running the kubelet with CPU policy of static and then giving you a no op result.
I think actually it returns an error, and I think it bails in the container launch.
Okay. By the way, I think we can probably handle all those things in like code review, but from like, maybe we can take the remainder of the 10 minutes to talk through just high level goals here in the design to make sure we're in agreement on that.
Yes.
Sure. So in terms of the allocations, the state is actually, it only holds one assignment per container ID. So if it does flap, I think we wouldn't continue to allocate things from the shared pool until it's exhausted. But, sorry, was there a comment on the line?
Hello. Yeah, Connor.
Yes.
Oh, so yeah, I wanted to say that probably was my patch where I added that it actually bails out and restarts the container if it can't allocate the CPUs. So that's how it behaves, at least now.
Okay. Well, if we just keep the notes captured, I'm sure we can make sure we checklist it in code review section.
We can review that offline as long as the overall like logic.
Okay. Vish, I think you cut out there. You were saying we can review it offline?
Yeah, I was saying that as long as the algorithm and the logic is available in the proposal, we can review it offline because this meeting is
Okay. Let's see. So we've got only a few minutes left. What do we want to prioritize? We've got.
So I had a couple of questions. Maybe we can prioritize on that. So I'd like to understand what happens when a node has best effort pods and guaranteed pods land on that node and the shared pool is exhausted. How are we handling that situation? And then the other question I wanted to know was, for those who haven't caught up on this proposal, like it's basically a configuration flag on the kubelet to say how we manage CPUs right now. If I'm running the static policy as a user, can I discover that from the kubelet either via label, or am I expected to manage my nodes myself? So basically, if I wanted to direct my workload to a node that had policy on, are we making that easier for you, or is it just something I need to do separately? And then what happens when the shared pool is exhausted?
Is that something that's typically done for other options, just to add a label?
Like we give you a label for the architecture, right? But I guess I'm not saying we must do it. I just want to know if we've thought about it, and then like have a note on that one. But then the more pressing issue for me was how we handle the shared pool when it's exhausted.
Okay, I can scroll down to that section in the doc, and then Seth, do you want to take that? I know you've been
Yes. So
doing
yes,
work on it already.
I need to write this part of the proposal, but the design right now is to allow exhaustion of the shared pool, and when that happens, to evict all burstable and best effort pods that don't have CPU requests, and basically the ones that, as far as the schedule is concerned, occupy 0 CPU and therefore can land on any node, even if there's no free CPU. And then set a node condition, CPU pressure, to indicate to the scheduler that you shouldn't assign us pods that don't have a CPU request.
Seth, you might also want to consider providing an option to reserve some amount of CPUs just for these scavengers.
We could. We discussed a different option. It would basically be an option to the policy, which would be kind of like a low water mark for the shared pool. We say always keep it at least one CPU around, and don't give it out to guaranteed containers. Yeah, we
and
could
basically by setting that flag, you would avoid CPU pressure ever being set.
Exactly. Yeah.
I think you have to, by default, at least give one as the shareable or maybe public. Because, like, for example, the Kubernetes, Docker, all those daemons running, and they're pretty much not reserved unless we want to reserve the CPU for those. And they pretty much will compete the CPU resource with all those burstable, all those kind of the best effort. So you have to, I think by design, we have to have those things.
Yeah, so we're honoring cube reserve and system reserved when we create the initial pool of CPUs. And so if you like say cube reserve or system reserved equal to 1, it's going to pull out the ceiling of the reserved CPUs, and those won't be part of the shared pool and guaranteed pod. These pinned guaranteed pods won't be pinned to them either.
So the only thing that's missing then is the best effort then, right? So we could obviously have protected our kubelets, basically anything in our system service. So
reserve is less than 1. It's not integer, then you are pretty much have to share, right?
If you set cube reserved to anything greater than 0, then we're looking at taking the ceiling of that. So if you set cube reserved at 100 millicores, then from the standpoint of the set of CPUs the CPU manager looks at, a whole core will be missing from that set.
This is a section, whether it's ceiling or floor is something that we could debate also.
Typically, you might want to just reserve CPU 0 because that's the one that gets most of the interrupts, I guess. So
In the proof of concept, that's actually what we did. And we can do that to avoid, pathological cases that we haven't imagined.
Okay.
So what we do is we, when we determine the number of CPUs that the CPU manager actually manages for pods, for user pods, we start at the high end and work down so that if you have anything reserved for cube and system, it'll include core 0. And that allows you to also set up things like, if you want to, set the CPU set for your system slice, or potentially in the future even use a simple ISIL CPUs policy, you could do that. Your high-numbered physical cores could potentially be reserved in that way.
Yeah, the only gotcha for just blindly reserving core 0 is that the math doesn't add up for the scheduler. You're out. If you don't set cube reserve or system reserved, then capacity equals allocatable, and you could try to schedule. If you got a 4-core box, try to schedule 4 1 CPU guaranteed pods on there for pinning. But there's only going to be 3 available in the CPU set because you reserved core 0 but didn't tell allocatable and therefore the scheduler about it.
Yeah, so I think that's like a side effect that we should require, that when you run with this CPU policy, that you had to have set system and cube reserve to something. So
I definitely think that's a safe requirement. To me,
Yes,
it's perfectly
like
natural. Yep.
So we have 1 more minute here on this topic before shifting to topic 2. I think the comments I asked were the ones that stuck out to me when I reviewed this yesterday. Maybe we can just close out on what we were looking to do in 1.8 and then.
Yeah, absolutely. All right, so at the bottom, we've got a kind of an implementation roadmap. It's a bit speculative, but in broad strokes, it's still accurate. And so in 1.8, what we want to get done is the none policy, which just does nothing. So this should be equivalent to current kubelet operation today. And phase 2 is the static policy, which is the one that's outlined in detail in the rest of the proposal. And basically, static refers to the lifetime of the CPU allocation for high priority stuff, meaning that once it's assigned, it doesn't change for the lifetime of the container. So we can get fancier with dynamic policies after that, but really we just want to get to phase 2 in 1.8 for alpha. So that's it. And I'm 30 seconds over, so I'll hand it over to Renaud.
I don't, maybe, is there something that maybe Jae wants to start with? Or is Jae here actually?
Yes, I'm here. Sorry. Okay. So yes, actually, Renaud, could you put present your PR if you want?
Can you increase the speaker volume?
Give me a second. Sure.
Sorry.
Yes, maybe I will.
Yes, could you hear me now?
Yep.
Yes, Renaud, do you want to present your PR? If you want, I can present it.
So Balaji just reminded me one thing. We made a demo video, so I'm just going to post that in the doc, so you can go view it at your leisure. That's it.
I'm playing the PR right now. And let me share my screen. And desktop is good. Nice playing proposal. Can you all see my screen?
Yep, looks good to me.
Okay. So I think I might start with that again, as Connor did, is that the motivation, or at least the objectives for us at NVIDIA, is to be able to provide some kind of way to actually enable GPUs. And to do that, we need a few things, at least we consider the minimal set of features that we would like that makes GPU available in production clusters would be to be able to make those GPU available in the container, be able to health check the GPUs, and be able to run some kind of, or at least to be able to clear the memory and run some tests before starting the containers on the GPU. So this is actually what we're doing right now with our customers, is that before they launch long-running, for example, deep learning training jobs, we usually have a small testing period where we make sure that the GPU is in a sane state. To do that, we've been discussing for a month, I think, or maybe two, about a plugin system that would allow other vendors to do that too. So it would not just be specific to NVIDIA. I think this is the basic objective. Should I represent everything in the PR? Is someone here not aware of what we've discussed?
I don't think we need to go through the whole PR again. I think I hope we can quickly resolve some open questions during the rest of the meeting, and so that hopefully after this meeting we can start the reviewing process on the code. This is reasonable to everyone.
So I can maybe speak a little bit for that. Hope everyone can hear me. I think a lot of this issue of having some more open issues with the existing proposal last week, and I think Jayang then went ahead and posted a doc that listed the different production corner scenarios that were not yet addressed, and also tried to question whether do we need all these different APIs. And so if we can just basically walk through those questions and get a consensus there, and assuming that others in the call do not have any more concerns, then I think we can go ahead with the review process, as Jayang was saying.
Yeah, exactly. Thank you. I think you can. So it looks like you already have the document. Go down to this section. I think one question we discussed over the past week is whether we want to support allocation phase in 1.8. I think you have explained the reason why you think this is an important feature to support in the initial prototype. And we definitely agree this is a feature we think we definitely want to support. I think at the beginning, our major concern was the failure recovery would become complicated. So you mentioned I think the policy you would like to implement is if for some reason device plugin becomes unavailable, then for all of the devices already allocated, you will assume they are still in good state, but you will make the allocatable device drop to 0 until the device plugin reconnects back. Is this a correct summary?
So what actually my thinking was that the goal that the design document is to be able to upload device handling to a device plugin. And so my thinking is that if we do that, if the device plugin is not available, then we should not allocate containers that request a device. If, however, containers are already running, we should not stop them unless they fail. But the basic idea is that if device plugins are not here, since they are in charge of allocating devices, then that means that there's probably something wrong, or maybe there's not something wrong, maybe we're just updating. But in that case, we should, my thinking is that we should not be able to allocate, or we should not even advertise those devices.
So are you in that case, are you going to update your device, whatever format you represent allocatable? So you are going to make sure your device allocatable, those OIR since it match existing container. So you already have the running container allocated with the device.
Yep.
So are you going to update that one just match already allocated?
If it's
Until
already allocated, we do not stop the container.
I understand. Your goal is not to stop those containers, but when I was as the user, when I view that node, can I see that one? So you are going to change the allocatable, the device allocatable. Are you going to update that?
Can you repeat your question?
So the question, so I guess the question is, if a device goes offline, say if the device can go offline due to various
reasons, right? Like it can go offline because like the device, sorry, I'm hearing some feedback and that's why I'm getting confused. The device can be marked as failed if either the allocate phase fails or
the device plugin.
Or the device plugin returns a health check marking a device as failed. So in either of those cases, will the capacity of the device drop? The advertised capacity from the node of that given device?
Yes. If a device is marked as failed.
I think you're on mute. Or maybe not, sorry.
Can you hear me?
Yeah.
Yes, now.
Okay. So if a device is marked as failed, then and it's not running in a container, then it's made unavailable and the capacity of the node decreases by 1. If the whole device plugin fails, then the capacity of the node is decreased by is removed, at least the device capacity.
That's sort of odd though, because you have pods that are already running and using those devices.
Right, but you're not advertising on the node the devices. Oh well, you could advertise the devices that are running in containers, right? But I think that's mostly a detail, right? The question is more about is this the right approach?
Well, I mean, I think there's still a little bit of thinking to be done here. What are the reasons an allocate call can fail? Like, I think we need to walk through that and like, would we retry? Like that's a question to answer. And if so, like how many times would we retry or how long would we wait before we give up on a device? Because we don't want to like keep ping ponging.
Ping pong, what do you mean by ping pong?
What I mean is like, you try once, then the device fails, and then the next update you get is this device is healthy. And you just keep going back between these two states.
Yes.
Like this is sort of hypothetical in that like, if the plugin is implemented properly, this is probably not going to happen. But then there could be like some scenarios where this is happening, like maybe the plugin got wedged in the kernel, like it's making some syscall or something like that. But like we should just know like what the failure handling is in that scenario. It's not that like, hopefully we'll not encounter that all the time.
So my question is, well, first of all, a solution could be that we have a counter that says if you're ping-ponging, then you're marked unhealthy. But the question that I would like to ask is, that is a problem that we will encounter whether we implement it in 1.8 or 1.9. Right. And so I think the discussion for today is more about should we implement it, and it is about, because my understanding of the design document is also of Jiaying's design document is also that she's also asking if we should implement allocate at all, right?
I think my proposal was just to delay that feature till 1.9. It's not like we should implement that at all.
I couldn't hear you on that one.
Yes. I think my question, no, my proposal was to delay that feature till 1.9. It's not about like not implementing that feature at all. So I agree this is an important feature, and I think it's okay to make it available in the initial prototype. But I just want to make sure like by introducing this feature in 1.8, we also have the proper failure handling, like at least the reasonable failure handling.
So my question is, there might be some bugs that I mean, some very tough situation where, for example, as you were saying, the device might ping pong. My thinking is it okay that some errors we are going to think about those during the implementation phase, and we might not be able to handle all of them because we didn't think of all of them. And my question is it okay to not be able to handle or forget to handle a few errors instead of not giving the feature at all?
So personally, I think we will hit ping ponging. Like I'm thinking in my head that like we say sometimes we'll hit it. I'll feel like we're hitting it all the time. Like I just know it's going to happen. Mm-hmm. And so like I would like us to mitigate the effects of oscillating conditions or ping ponging device states, either by doing what we do for other things, which is like require some steady state before transitioning out of that. But that seems like a pretty minimal requirement to just make sure we capture in the design. So it's like we say we won't hit this, but those of us like supporting this will feel like we're hitting it all the time.
Right. So I think my question was more about not about hitting ping ponging, was more about there are some failure cases that we might not think about, and that my question was more about, is it okay to not be able to handle some errors, or is it better that we do not implement allocate at all? Because I think this is the real question that is asked by Jiaying, right? Is that because we're not able to handle all the errors, then we should not allocate in 1.8?
I personally feel we need to handle allocate based on the, at least for the GPU cases. I also can think about some other device we need, unless we find some other way, and to, like for example, long time ago, we mentioned to like we have the pluggable, like a fellow ladder, and or maybe initializer pluggable. So and it could be extensible. Like just like the normal, like the callback or closure approach. So you can default for those kind of things to support, and you are doing this kind of clean up or initialization work. So unless we have those kind of things, and to make this feature usable, especially for the GPU's case, I think we have to support allocate. Mm-hmm. This is my personal opinion.
Sure, if you're looking at me, but...
I don't know why I'm looking at you. I was thinking, sometimes I look at different targets, sorry.
So yeah, so I agree, like allocate is an important feature to support, and it's totally fine, like we make this feature in the 1.8 release. I think, so just a couple of thoughts. One is like, is it possible we make this allocate callback optional? Because for certain devices, they don't really need this device specific allocation operation. Like for example, high performance NIC, we probably don't really need to reset the device or run any testing on the device. So like people have options to choose whether they want to provide this allocate interface or not.
So you want to provide an option on the option?
So for example, like in registration, you have the device plugin to send the Unix socket to Kubernetes. So is it possible if like a device plugin send that empty string, then Kubernetes knows it doesn't need to make this callback during allocation. Then I think the benefit is for this type of devices, they can do the like a hitless upgrade because it's not it doesn't need to get involved in the like a device use cycle.
Actually, this is a good point. I want to ask you one thing. So normally when you set up that one, do you mostly is referring to like clean up, reset, all those kind of things? Can we just, when we stop, when we unbounding, unload those, it's possible we already, to as the clean up stage, we can already get those devices ready. So then in that case, we don't need allocate. Because all I sounds like from your proposal and also the comment back and forth, most of the allocated is just for setup, for clean up, right? It's possible.
So allocate in our case would be for scrubbing the GPU memory and for running tests on the GPU to make sure that it wasn't put in a bad state by the previous task or by external condition. It is in a correct state.
So can we make sure that when it is being handled, like a previous test, for example, can you make sure that when you unbounding, I mean, this is wrong word, but you got, so when in the stop phase, so we introduce a clean up phase. So make sure that its device is.
It's different. The stop phase means stop device plugin daemon set. It doesn't mean stop.
It's not unbounding.
It's not unbounding a device to a user pod.
Yeah, I doubt the relevance of stop phase. We should probably remove that, but like we can discuss that offline.
Yeah, but okay, forget about the stop phase. I'm using the wrong phase. So when you unbounding that device to a pod, can we clean up? Can you do those kind of things? So in that cases, you don't need actual allocation phase.
But you will need the deallocation phase.
Yeah, but anyway, you have to put that to reclaim, right? That resource.
Mm-hmm.
So anyway, even we don't explicitly put that allocation phase, actually you are implicit have that phase.
But then you will have a deallocate.
What phase are you talking about? When you allocate?
I'm talking about new phase. I'm sorry.
So we did originally propose the deallocate phase,
okay.
but then over time we figured out that like everything that we wanted to do in the deallocation phase can actually happen in the allocation phase itself. So we decided to get rid of it.
Right. So if we want to talk about new addition to the proposal, how about we talk about them on the proposal and discuss about the features that we want to see in 1.8 for the last 10 minutes we have. Does that seem reasonable?
Yes. So I think, I think overall my feeling for allocation is it's great to have it in 1.8. I just want to make sure we have reasonable handling on failure cases. That's all.
So my understanding. Sorry, go ahead.
No, I was just going to say that you have a section on health checks and failure recovery in your proposal, so we can probably review that and like use that to use that to synchronize. In terms of like what we can do in 1.8, like honestly, we have 5 weeks, and we can't like take a whole big PR done. So I think we cannot like compromise quality either. Like we have an alpha goal, but if you just like have to review a huge PR, we're definitely going to miss some issues, and then like debugging that and fixing that is a huge pain, as we have seen in the past. So let's try to be as optimistic as possible and like try to break down the implementation in the small pieces and review it.
Vish, we're talking about one API call more or less right now. Is that correct? We're talking about the allocation phase.
I'm sorry, I guess I moved on. Maybe I should have said that explicitly. I'm still there are a few more parts of this API that I want to question, like the heartbeat and stuff. But I was hoping we can discuss that offline and not necessarily here. I was saying that in terms of the implementation of this API, like after some of the rest of the things that we are now stating that we will discuss offline are actually discussed, and we have settled down on the specifics. I'm talking about the implementation of the API itself, and I'm saying that we need to break down the implementation into like smaller patches where we can actually review it and we can understand what is actually going on in there.
So I agree, but then what I wanted to actually understand is that if we go and implement Jiaying's proposal, is it realistic to think that it is going to take quicker? The Jiaying's proposal is different from this one. There are a lot of different parts. It's not implemented, and it really has no real way forward to this proposal. And there are a lot of things that we are actually going to also discuss on this proposal. So I'm also concerned that we're going to run into the exact same issue that you're raising on my proposal.
I think we only have like less than 10 minutes left. I don't really want to argue like whether it's one way or the other. As I said, I'm okay to include the allocation and two-way gRPC in the initial proposal, in the initial implementation. We just need to like have a good understanding on the failure cases. I actually want to move to the second topic. I think it's more important. That is how we can recover from kubelet, because the current implementation push kind of using node status and container status for checkpointing the allocation state. And I hope we can reach an agreement on that, because I thought from our past discussion, we have decided like we don't want to introduce too much API change between kubelet and the API server in the 1.8 release. Instead, we want to use extended ORI to avoid that. So, to recover from kubelet failure, we can implement some local checkpointing to record the allocation state. So I just want to reach an agreement on that, because that part I feel like it seems more important, and we really hope we can limit the scope on that.
So actually, I have just another concern on this, is that your argument is that we want to break it down into multiple PRs, and that we don't want to have a lot of code, but then you're actually adding checkpointing, which is probably more code, in my understanding. And I just think that maybe I don't have a clear understanding of what it really takes to change the API, but my understanding is that we could just mark those features as alpha and then move to checkpointing in 1.9.
I would so there is no urgency for us to get this feature done in 1.8. Like honestly, if this slips into 1.9, that's perfectly fine. I would much rather do it properly over time, rather than like do something now, get rid of that code, and then do something else. Like we're not going to delete the existing implementation for NVIDIA GPUs in 1.8. So it's not that like people will be left stranded who are our current users. And even if we have this alpha implementation, it's not that their life is going to significantly improve. So like, given that user side assumption, I would much rather avoid making short-term changes.
But wouldn't it be significantly better to actually have, or at least save a one release on production-ready GPUs?
Well, it's not really production ready, right? Like this.
I'm not saying that it would be 1.8 production ready. I'm just saying that if we slip allocates in 1.9, then we cannot claim that 1.9 is better. We're actually one more release, right?
Yeah, we won't get like production experience, but basically what I'm saying is like I don't want us to make decisions now that we'll just throw away like as soon as 1.8 gets cut. Like if the API change, if you're going to do checkpointing in 1.9, we might as well do it now. And like we have people to do it, right? Like we have like at least 2 or 3 people working on this. So I don't see why we cannot do it.
But okay, so in that case, so we can add people to do checkpointing, but we're concerned that allocate might be too much. Is that what I'm understanding, Bish?
That was the old situation.
I think you misinterpret what the giant say. Giant actually agrees.
Sorry if I passive aggressive. I'm sorry. I'm just trying to understand.
I try to summarize what's the giant. Correct me. Giant's statement here. Giant actually is okay with we introduced allocate. And she only asked one possibility, make that it's optional, it's not required. And that's also, it is not a strong preference from her. And my understanding, she is more concerned about the new API change you introduce, try to avoid checkpoint. My understanding from what you propose, it is you try to avoid the checkpoint on the local node, and you try to do the remote checkpoint through the API server. So that's the kind of giant concern, because from also my same concern. And I like what the API change you put there. The only things I unclear it is for me, because you introduce that device struct And I'm not sure that device struct is abstract enough to cover other devices. I understand it's cover your current GPU cases, but I'm not sure. So I was but I like that you have this container status and which it is, which device bounding to the container, and you have those information, which is help us to look at the improve the debuggability and also all those kind of things. And but the problem is I just not familiar with that device struct. Is abstract enough.
So to be clear, as long as we're able to push allocate in 1.8, if we do device checkpointing, I'm okay.
Okay, that sounds reasonable.
My
Yeah.
goal is not to change the API or anything. What I would like to see in 1.8 is be able to allocate and be able to run GPU memory scrubbing. I'm okay if we're able to do checkpointing, then I'm okay. I just my idea with changing the API is that it offers introspection capabilities and it solves this checkpointing part in a few lines of code.
Okay. I think that sounds reasonable. So, and I hope like when we are going to the code review part, you will be able to remove the changes on the node status and the container status from your PRs. That sounds.
So can I propose something? One thing, actually, I like the one you propose, like have the container stats, have some device. Like what I already mentioned that I think about, I'm not comfortable at the device struct at this moment. It's because it's really GPU specific at this moment, and but we do want those information for the whatever debuggability. And can we just simplify that structure?
Actually, I feel like if we should go with the goals. If the goal is to introspect and debug what's happening in the node, we can have separate APIs. I don't know why we have to overload user-facing pod APIs with all this
That's
cluster administrator. Yeah,
that's user-facing actually.
Which one?
It is user-facing.
Wait, I'm saying that users might not care. They care about their declarative API, right? And they care about what went wrong. They don't necessarily care about which exact device number that they were attached to, or what exact properties were, because they already explicitly specified whatever properties they care about. Most likely this is a scenario where cluster administrators want to figure out something going wrong.
Counter proposal? Yeah.
Have a debug API in the kubelet that exposes this information. It's a kubelet level feature, so it's a kubelet API, not a.
Which you argue a lot of things for long-term things.
We can discuss this offline.
And we differed a lot of things for future, but now you told something like the rush for the debugger API. That's even longer.
Let's focus. We only have a few minutes left. Let's focus on what the decisions are. My understanding is that we're all okay with an allocate phase. It's just that we would like it to be optional. I'm fine with it, and I think it's a good thing. And I mean, at this point, the API, how we implement checkpointing or failure recovery, whether it's checkpointing or the API or another method, I think can be discussed offline, right?
As long as people in the call do not have opinions on that, I think it can be discussed offline. But now that we are out of time, it has to be discussed offline. So this week, let's have a deadline for getting your proposal reviewed. And if anyone has any opinions on it, I think by this week that should have been voiced. And so we can focus the next 4 weeks on just the implementation.
Just for my own clarity, his proposal now combines both the documents we had reviewed last week.
Yes.
Are now one proposal we can rally on to read the GPU stuff or device stuff generally, or do we still have to split our time across 2 docs?
No, I think at this point, my assumption is Renault's proposal has all the thoughts that have been circulated so far in different medium already incorporated.
Okay.
So I hope we can actually merge the 2 implementation proposals into one.
Which is already the case, right?
Yeah.
Okay, so we are
I'm
out of time.
confused. So should I review the PR? Not because I didn't never read that doc. I only look at the PR.
Yeah, I
So
think
the PR is okay. Okay.
Yeah, the PR is a detail.
Up to date.
PR is in the proposal.
Yes.
Yeah, the community proposal.
This one.
Yes,
Okay.
yes.
Awesome.
Yes.
We are 2 minutes out of time.
Yeah, so I think we have still a couple of questions like whether discovery and it's necessary, whether we need 2 RPCs, but I guess we can discuss that over the comments, like the PR comments.
Right.
Yeah, and hopefully for the next week we can have a single PR doc. That is the plan going forward. That sound okay?
Yep.
All right. Well, thanks everyone for presenting today, and I think we're making a lot of progress in the group. So,
hello.
Next week.
Yeah, good job. Good to see some more agreement on the proposal, and keep it up, Renaud, and everyone. You're doing a good job. So.
Yep.
Thank you.
Bye-bye.
Hey, Connor.
Thanks.